All right, let's move on to part 2 here, and I want to talk about the next theorem. So this is called the polygon exterior angles theorem. So I want to remind you about an exterior angle, and if we just look at triangles, if I draw a triangle, of course it has 3 interior angles here. I'm just going to put 1, 2, 3. 3 interior angles. But I can take any of the 3 sides and extend it out. And I have created this outside angle here. And that's called an exterior angle. We had a property with triangles that said that this exterior angle is equal to the sum of the 2 remote interior. Okay, so that was from an earlier unit. Now we're going to talk about polygons, so any number of sides. Okay, so we've got, here are several exterior angles. So for every interior angle, there is an exterior angle. So the polygon exterior angles theorem says that the sum of the measures of each exterior angle of a convex polygon is 360. So this is different than the interior angles. No matter how many sides a polygon has, all of the exterior angles add up to 360. For interior, remember we had this formula. Let me go up here. This n minus 2 times 180. So as the number of sides increase, the interior angles increase. The exterior angles remain unchanged. Okay, so let me show you, I have a visual here. Okay, oops, make sure it'll work. I want you to watch this. Do you see how the exterior angles, if we take all the vertices and shrink them on top of each other, do you see how all the exterior angles form a circle? And if you recall on circles, all circles have 360 degrees. So that is why it doesn't matter how many sides a polygon has. Think about this shrinking visual. This is a really good visual, I think, to help you understand why in the world it's always 360 for exterior, but interior it's 180. Okay. Oops, let me go back here. All right, let's take a look at a few examples here. So the key on these problems is to read whether you are using interior or exterior, or if you have a diagram, use your diagram. All right, find an unknown exterior angle. Okay, so find the value of x in the diagram. So what I see here, these are all exterior angles. So I am going to have to add them together because I know here that they add up to 360. Okay, so I can write an equation. So I can take each of those angles, x plus 65 plus 63 plus 92 plus 112 equals 360. And from there I can solve it. Okay, so let's add all those terms together. 65 plus 63 plus 92 plus 112, 332. So x plus 332 equals 360. So let's subtract that from both sides. So 360 minus 332 is 28. So x equals 28. Okay, so I had to visually determine those were exterior angles, and then I had to know they added to 360. Okay, number 5, find the measure of each interior angle of a regular decagon. Okay, interior, I'm thinking of the formula, n minus 2 times 180. Regular, I'm thinking it has equal sides. So I'm going to just make a couple notes here. And decagon, I need to know that a decagon has 10 sides. So I want to find the measure of each interior angle. So I'm not going to be able to draw a decagon, so I'm just going to try to draw something with a lot of sides, just to give you a visual. What we're trying to determine is the measure of each of these angles. Okay, I want to know how much individually they are. And I know that they're all equal. So I'm going to say equal sides angles. Okay? All right, first of all, I need to figure out how much all 10 angles add up to. Because if I know they add up to a certain number, let's say they add up to 100, then I can cut 100 into 10 equal parts by dividing. So I'm going to start with what is the sum of all 10? So I'll do n minus 2 times 180, so 10 is the n. So I'm doing 8 times 180. 180 times 8 is 1,440. Okay, so this is the total, all 10. But I need just each of them, which means I want one of them. So I'm going to take what they all add up to and divide by the number of angles that exist. So there are 10 angles. So I would, when I divide that out, okay, remember you can do this like divide by 10, just takes a 0 away. So I am determining that each angle is 144 degrees. Okay, so we really want to read the words and make sure we're understanding what we're actually calculating. Okay, I want you to try the last one. Pause the video and then see what you can come up with, and then come on back and check it. Okay, I want the measure of each exterior angle of a regular 20gon. So there's a couple ways to do this. I'm going to do the same process I did before. If I know what they add up to, then I can split them into 20 equal parts, okay? Because remember, this word means that you have all equal angles. So I'm going to just say equal parts because you can do sides or angles. Now, when I see the word exterior, I know that the total of all 20 is 360. Okay, remember there's no formula involved on exterior. So if they all add up to 360 and there are 20 of them, let's just do 360 divided by 20. And so that would give me 18 degrees. Okay, so the other way to do it is figure out what is the measure of an interior, and then each interior is supplementary to an exterior. Like take a triangle, for example. So if this interior is 60, the exterior is 120 because they are a linear pair, okay? So you could always use that idea. If you can find one of the interior, then you can do a linear pair to get to the outside. Okay, so we'll maybe touch on that on some other examples. Okay, so that wraps up polygons, interior angles and exterior.